In the last quiz, we were trying to figure out how to give the Tom, Tim, and Todd text views a little more personal space by spacing them out equally vertically across the height of the device. We tried setting a fixed DP value, but that wouldn't work if we switched to a taller device like a tablet. Then we tried match parent, but then that made the Tom text view really big, but then it knocked the other two text views off the screen. So then we started researching about linear layout weights. In the documentation, it said that for a vertical linear layout, if we want to equally space out the children, we need to set the height to be 0 dp and a weight value of 1 for each of the children. Assigning a weight value to a child view is like assigning an importance value to it. The higher the weight value, the more space it may get if there's available space in the parent left. So for example, for this vertical linear layout, it fills down vertically this way. It turns out that this linear layout has a lot of extra space, and that will be distributed to the children that have weight values. If a child has a very high weight value, then more of this available height will be given to that child. If a child has a very tiny weight value, then less of this available height will be given to that child. I can show you what it looks like. I'm going to set the height of this child to be 0 dp and then give it a weight of 1. The linear layout first lays out Tim and Todd text views because they have a fixed height based on the content inside of it. And then there's this Tom text view that has an initial height of 0 dp but a weight of 1. None of the other children have a weight value because the default weight value is 0 if it's not specified. So this is the only child with a weight value, so the parent gives all of the remaining height of the screen to this Tom text view, and that's why you see the Tom text view is like so giant. Let me try assigning weight values to the other children now. So now each child has a height of 0 dp and a weight of 1. This is the process that the linear layout would go through. It would try to figure out the height of each of these views. The height of these views starts at 0 dp, so that means the available remaining height in the parent is basically the whole height of the screen. It divides the whole height of the screen by the weight sum, which is 3, and then it gives 1/3 of that available height to Tom text view, 1/3 of the height to the Tim text view, and 1/3 to the Todd text view. These will still be evenly spaced across the height of a device, even on larger screen devices as well, because of this weight value. If I change the weight value to be something higher, then the parent will give more available height to the Tim text view. I can change it to an even higher weight value, and you can see how it continues to get more available height. In this case, the Tim text view has a weight of 8, Tom has a weight of 1, and Todd has a weight of 1. So the weight sum total is 8, 9, 10. So the parent divides the available height divided by 10, and 1/10 goes to Tom, 8/10 goes to Tim, and 1/10 goes to Todd. So for a vertical linear layout, say we have 3 child text views. We set the initial height to be 0 dp, so they're all stacked up at the top of the screen with 0 height. That means the parent has all this extra height available. If I set a weight of 1 on each child text view, then the available parent height will be distributed equally across each of the children. The same would work for a horizontal linear layout. Say we have 3 child text views. We start with a width of 0 dp. That means the parent has all this extra width available. If I assign a weight value of 1 to each child view, then we're going to take the available width left in the parent and distribute it equally among each child. And again, it doesn't have to have a weight of 1. It could be 2, 3, or any other value, or it could even have a weight of 0. If a view has a weight of 0, that means that it won't change depending on the available space left in the parent. It will basically stay the width and height that you give it. One thing I want to point out is when to set the height to be 0 or the width to be 0. If you have a vertical linear layout, you're filling the linear layout vertically this way. So you don't know what the height should be, so you set the height to be initially 0 dp and you give it a weight value. Similarly, for horizontal linear layout, you're filling it horizontally, so you don't know the width yet of the child views, so you set the width to be 0 dp and give it a weight value. Essentially, you can think of assigning a weight value to a view as being able to stretch it out depending on how big the parent view is. This is good for filling in the available space within a small device or a large device. Here are a couple examples in real life where layout weights are really useful. This is the Google Hangouts app. You can use it to chat with your friends or send sleepy penguins to them. In this bottom part of the screen here is where you send your message. Let's look at this layout down here a little more closely. It's a horizontal linear layout because it's laid out in a horizontal row. It's made up of an image view, an edit text field where you can enter text, and then another image view. Now the height of each of these views is actually wrap content because it wraps to the content inside of it. The width of these two image views is wrap content because it's only as wide as the content inside of it. We give it a weight of 0 because we don't want it to be any bigger than this, even if there's lots of space in the parent left over. Setting the weight of 0 ensures that it will only be wrap content for width and height, and it won't change. We want it to stretch so that it's a little bit bigger on larger screen devices, and we want it to shrink if it's on smaller screen devices. So we set the width to be 0 dp and the weight to be 1. That means that the parent linear layout will try to lay out this image first and then this image, and then any remaining width in the device will be given to this view. Here's an example in the Maps app. This is a detailed page for a location. There are 3 buttons here: Call, Save, and Website. Let's look at them more closely. You can actually build these as text views with icons attached to them, and you can see the instructor notes for more details, but that's really a tangent point. For this exercise, let's assume that these are text views. The height of each text view is going to be wrap content because it wraps to the height of the content inside of it. Now the width is a little bit trickier. We want each of these text views to be spread out equally across the width of the screen, depending on whether it's a small device or a really large device. We don't want all 3 text views to be grouped into the left-hand side of the screen. So to space children out equally, we give them equal weights. We set a width of 0 and a weight of 1 for each of them. That way the available width in the parent will be spread out equally across the 3 children. And the last example is an email app. This is a compose screen in Gmail where you can write a new message. It's a vertical linear layout because the items are in a column, and it's made up of 4 different edit text fields. Now the width of each child is match parent because we want it to stretch across the whole width of the device. For height, we set these 3 edit text fields to be wrap content so it wraps the text inside of them. We set the weights to be 0 because we don't want them to increase in size even if there's available height in the parent. But for this last edit text field, this is where you write your message, and we want to give the user lots of space to write a really long letter to grandma. So we set the height to be 0 dp and we give it a weight of 1. So if the parent has any available height left, it will be given to this child edit text field. On a larger screen device, the compose email field will be a little bit taller, and on a smaller device it will be a little bit smaller. Now it's your turn to practice. We want you to go ahead and build this layout in the XML visualizer. You can start with the XML that we've provided below. Here are a couple tips. When you try to tackle something like this, try to first determine the width of each view, and then go ahead and try to determine the height of each view. Also, make sure that the image takes up any remaining height in the parent linear layout. So on a smaller screen device, it will take up less height. On a larger screen device, it will take up more height. Okay, go for it. Check this box when you're done.